In previous videos, we discussed about the geometrical optics. In the geometrical optics, the properties of light whenever it is reflection and refraction through the different phenomenon observed when lenses and mirrors we discussed, and as well as by using the lens and by using the mirrors we derived a formula for mirror and lens formula, as well as what is the use, how do we construct telescopes and microscopes we discussed earlier, and the defects of vision also. In that case, the reflection and refraction can be discussed in terms of when the light is a particle nature of light. Particle nature of light we discussed, but the particle nature of light does not satisfy the all the properties like diffraction and another things also. In that case of interference, diffraction also. So in that case, the Huygens proposed that it is having the wave nature of light. In that case, wave nature of light. In that case of wave nature of light is satisfied the phenomenon of diffraction and interference and another properties also. So that's why particle nature of light does not satisfy the interference and diffraction, and earlier the particle nature of light does not described, does not told about that any discussed about the another properties of the light, only discussed about the reflection and refraction. In the case of the nature of light means particle nature of light is discussed reflection and refraction, and another properties which are diffraction, interference and other things also does not discussed about that whenever the particle nature of light. No, Huygens proposed that the wave nature of light, whenever the light is wave having the wave nature, then that phenomenon is discussed in the physical optics means wave optics. Physical optics means wave optics. We are going to discuss about that wave optics means when the wave nature of light is there, light is having the wave nature, then what are the properties which is contained. So here is that we are going to discuss the main topic is that the wave front. The wave front. What is meant by the wave front? Wave front means when the light is traveling from the source, the points which are vibrating in the same pace, the locus of the vibrating particles which is vibrating in the same pace of the light is called a wave front. We can say that here that the continuous locus of all the particles means here that the locus is there, the continuous locus which is our total are vibrating in the same pace, total are vibrating in the same pace. Whenever the source from this space, whenever it is traveling this is a diffracted wave front. This is considered as a diffracted wave front. Whenever the light is passing from the source, it's a point source, consider it's a point source. When it is passing that, then from the source it is diffracted. This diffracted means diverged wave front. It is a diverged wave front. So that in case of we are saying that the locus of all the particles are vibrating in the same pace is called as a wave front. In this case of wave front, we have the different types of wave fronts is there, that is plane wave front, spherical wave front and cylindrical wave fronts also. Here is that the continuous local means in this case of the wave front, all the particles are vibrating in the same pace, and also they are moving in the velocity, the speed is equal to the wave speed in that medium. So here is that we are discussing about that the points all locus means here is that this is the continuous locus of the all particles of medium which are vibrating in the same pace. In this case of the types of wavefronts are there, the spherical wavefront, cylindrical wavefront and plane wavefront. In the case of whenever the source is a point charge, when the source is a point charge, the light it travels in all the directions. In all the directions means whenever if we have the 0 watt bulb or 100 volts bulb, we are having that at home normal bulb, then that considered as a point source, that light can be traveled in all the directions, considered as a point charge, point source, then the light will travel in all the directions. So that in case of This is the cylindrical, means a spherical wavefront. Spherical wavefront, when the source is a point source is a point, and this is the light will travels all the directions, in all the directions. So that case of a spherical wavefront can be formed because of all the points of continuous locus, vibrating in the same pace. Because of the points where are the vibrating is unequally distance with all the particles having that equal distances. So that's why we can say that it is vibrating in the same pace. That is called, this is the wavefront. And in the case of a cylindrical wavefront, like we have the tube light at our home. So like that, whenever the pens is slit, when the slit is there, and slit, whenever through the slit, whenever the light is passing from that, then that is called as a, like this. This is the source, cylindrical wavefront source. Whenever it is vibrating, this is in all the directions. In all the directions, light can be traveled from the source. Then we can say this is the wavefront. We can say this is the wavefront. Means is nothing but when the light is traveling through that, then the wave nature, which is having the wave nature, in that wave where the points, all the points, the front side of the wave, whenever it is traveling through that, the front side is called as at t is equal to 0 at the initial stage. Whenever it is traveling, the front side of the particles which are vibrating in the same pace, that is called as a wavefront. The locus is called as a wavefront in case of in case of plane wavefront. Means either cylindrical wave or a spherical wave, whenever the least distance, if we have the large distance, if we see that, then both can be considered as, both can be seen as a plane wavefront. Means here is the plane wavefront when the light is passing straight line parallel to this, in case of whenever the light is passing from that, we have that the diverging or converging. So whenever source is point source considered, when the light is traveling from a source to the in all the directions, then the points which are vibrating in the same pace, this is called a wavefront. Means which wavefront is this one? Diverged wavefront. DWF means a diverged wavefront. If in case of the light sources are coming from and converged at a point, means like this, whenever converged at a point, light sources are coming from that and converged at a point, then converged wavefront, CWF, converged wavefront. These are the types of wavefronts. Now we are going to see that what is the wavefront, means whenever the Huygens principle, and also the important points we are going to discuss about that. What are the remembering points, means the important points we should remember while doing the wavefront concept. We are studying about the wavefront. So here are the some important points to remember about the wavefronts and whenever the light is traveling. Then we will discuss about some of the points. First of all, rays are perpendicular to wave from wavefronts. It's a wavefronts, from its wavefronts. So here is the source of the light. Whenever this is the wavefront, consider this is the wavefront, secondary wavefront, this is the primary wavefront. Means here is that at a t is equal to 0, that wave will be formed whenever the light passing from the source. Then from it also, this is the wavefront and this is the secondary wavefront. Means here the light rays are passing like this. This is always perpendicular. Rays are perpendicular to the wavefront. That is it. Next one, the time taken by the light to travel from one wavefront to another is the same along any ray. Means this is the secondary wavefront and this is the primary wavefront, and it is time t is equal to 0. At time t is equal to 0, this is the primary wavefront. This will be t is equal to after some time t. Then the time taken by the light to travel from one point to the another wavefront, means one wavefront to the another wavefront, and is the same along any ray. The total time taken in any ray, that will be the same ray. Means this is the perpendicular, and the time taken to travel by a light from one wavefront to the another wavefront is the same along any ray. Next one, every point on a wavefront is an independent source to produce secondary wavefronts. Means here when the light is passing from this, light is moving this, and one of the points are vibrating, this will be the considering t is equal to 0, that is the wavefront, and this is the independent. It is an independent source, means it acts like the source for the second wavefront. This primary wavefront behaves like acts as a source for the second wavefront. So here is that we can say that every point on a wavefront is independent source to produce secondary wavefronts. Means this primary wavefront acts as a source for the second wavefront. So that's why we can say that every point on a wavefront is an independent source to produce secondary wavefronts. The next one, all points on a wavefront vibrate in the same phase with same frequency. Means the distance will be same, the traveling distance is same, this is also traveling distance same, this is also traveling distance same. Means in the total particles, means whenever the total in that wavefront, every point is vibrating with the same frequency and also these are vibrating in the same phase also. So that we can say that every point, all points on a wavefront vibrate in same phase with the same frequency. And next one, wavefront moves with the velocity of wave in that medium. Means wave is nothing but when the light is passing through that, then it is also wavefronts also moving with the same velocity as the waves moves. The next one is the shape of wavefront depends on the source producing the waves. Means if in case of the point source, if the point source is there, then we know that the spherical wavefront can be formed for that, and also cylindrical for a linear source is formed. Means when the point source is there, then this is the spherical wavefronts. Spherical wavefronts can be formed. For a linear, there is a cylindrical wavefronts formed. Means it's a point source, and it's a linear source. For the plane wavefront, source must be at infinity. Source at infinity. Source must be at infinity for a plane wavefront. Plane wavefront infinity must be, whenever we already discussed about it, when if in case of a point source or cylindrical, means a spherical wavefront or a cylindrical wavefront for a long distance, whenever we watch it from the long distances, that can be considered for the which can be seen as a plane wavefront. So here is that the source must be at maybe at infinity distances, plane wavefront can be formed. In this case of a linear source, the cylindrical wavefronts formed. For a point source, then spherical wavefronts can be formed. The next, each point on a wavefront is a source of new disturbance called secondary wavelets. Means each point, whenever each point are vibrating, this is the wavefront. In the wavefront, these are the each point will a source of new disturbance. This is a source of new disturbance called secondary wavelets. Means these are called, this is 1, 2, 3, 4. These are called as wavelets. Means secondary wavelets. These are called as a secondary wavelets. This can be considered as a secondary wavefront. This can be considered as a secondary wavefront. In this case, due to the secondary wavefront can be formed. So that we can say that each point on a wavefront is a source of a new disturbance. Means due to this one, the disturbance is forming. Due to new disturbance called these are called secondary wavelets. These are the important points to remember about. We are going to study about the wavefront. Next, we are going to discuss about Huygens principle due to reflection and refraction. Huygens principle in reflection and refraction we are going to know.